You to another statistical topic. Of course, this course is based on communication and consultation in statistics. I remember you've been introduced to different kind of studies. We've done experimental study, we've done observational studies, and of course, the essence of using essence of conducting experimental studies or observational study is for us to be able to investigate relationship between variables. The variable could be the independent variable, we call that exposure, and the dependent variable, we call it outcome. So what we want to do today is we're still going to be focusing on observational studies, but what are the statistical techniques that we use as a measure of association in observational studies is what I want to unravel today. And that's why I call the title Measures of Association. So we're trying to measure association when the research design is observational studies. Now, in the outline, I'm going to walk you through what we call multiple exposure groups, because at time, I think based on what we've done before, we talk about like either people, participants are exposed or not. That actually implies two groups, okay? Where you have experimental group, you have the control group, but I also want to walk you through situation whereby we could have more than two groups. And that's why we call that multiple exposure groups. Then I'm going to talk about relative risk. How is it different from risk differences? And what kind of observational studies we can apply that? Then I'm also going to walk you through what we call the odds ratio, okay, which is also used as an estimate of risk ratio. Let's get started. I need you to take a look at this. Some individuals, we conduct what we call cohort studies, whether you conduct cohort studies, okay, or you actually, in a cohort study, we follow individual, okay, for a certain period of time. We're actually waiting for the development of certain health conditions or not, waiting for an outcome. And of course, we can also do what we call the case control study. But let me tell you this. Some cohort studies and clinical trials compare the risk of disease or other outcome among 3 or more. In case you've heard about what I call clinical trials, okay, and the cohort studies we have done, there's possibility that the numbers of exposure may go beyond two groups. Traditionally, we use two groups, right? Experimental group and the control. But take a look at this. Where 3 groups are involved, participants were exposed to magnetic field, and we got different levels of exposure, which ranges from low, medium, and high. When you take a look at low, medium, and high, in a situation where you don't have a control, we're actually going to use the lowest level of exposure as the control. So here we're going to make use of low. So if I want to analyze high exposure and medium exposure, it's going to be in relative to low. Does that make sense? Okay, now when you take a look at this, different participants were actually exposed to different level of magnetic field. And of course, after they were followed, okay, at a period of time, they actually record, we got an outcome. An outcome is either they have leukemia or no leukemia. Okay, so the levels of outcome here is 2. Okay, the development of the disease or no disease. Okay, but the levels of exposure, the variable that represent the magnetic field exposure has 3 levels. You can see high, medium, and high. I mean high, medium, and low. And take a look at this. You know, 30, or let me just say 674 were exposed to high magnetic field in total. 1,469 were exposed to the medium, and 67,424 exposed to low. Do you know that out of the 674 that was exposed, that was exposed to high, okay, it's only 30 that actually had a leukemia, and 644 do not. I want to believe you understand this table, right? Is anyone who doesn't? Go ahead. Uh, oh, okay. I got what you mean. Give me 1 second. I think there's something now. Here, this guy, right? Divided by. Can you use your calculator? Uh, because I want to talk about the cumulative. Use get 30. What is 30 divided by 674? Does that give you 0.0445? Do you want to check it? 30 divided by 674. Yeah, I think there's a mistake here. I'm so sorry. This one's supposed to be these. Okay, let me just circle them out for you. Use a calculator. That may be typographical error. Now use your calculator to confirm that. Let me just cancel this so that I don't mislead. Okay, so what is 61? 61 divided by 1469. Yeah, 61 divided by 1469 is 0.0415. That's correct. Then the last one, did you also check the last one? 2264 divided by 67424. Okay, that's correct now. So what I was calculating here is cumulative incidence. When you are calculating cumulative incidence, the ratio, the numerator is going to be the number that develop the disease divided by the totality of exposure. Does that make sense? The totality of exposure is 6741469. So what I was calculating there is cumulative incidence. Okay. Now, any question about that? Good, right? Okay. Now, how do we interpret this? Because having a probability value, how do we interpret that? Do you know we can multiply each of these by 1,000? Why do we want to multiply by 1,000? We don't want decimal, so that we'll be able to work with a number. Take a look at this. When I multiply each of them by 1,000, okay, the first one multiplied by 1,000 is going to be 33.6 per 1,000. If you want to look at it relative to 1,000, you multiply by 1,000. It is not only 1,000 you can use. You may want to look at it relative to 10,000, relative to 100,000. Does that make sense? Now, is there anyone who need clarification on how I came about this one? That is like converting the cumulative incidence. Okay, I want to be able to say something per 1,000. Now, I told you the other time, we do not have control, but in a situation where you don't have control, you're actually going to use the lowest level of exposure here. Okay, so which means you're going to compare the risk. If I'm talking about risk ratio now, risk ratio is comparing risk ratio between two different levels of exposures. So if I'm going to do that, I'm going to compare medium with low, high with low. Why am I comparing them with low? I'm using low as a control. Does that make sense? Now, how do we interpret this guy now? When we compare medium with low, anytime you have 1.23, that's a 33% increase, right? You remember mathematics? Take a look at this. 1.33, 33. So if I want to interpret that now, I'm going to say, compared to children exposed to low magnetic field level, those exposed to the medium level have 1.23 times the risk of leukemia. What if the ratio is 1? 1. Okay? If the ratio is 1, if the ratio is greater than 1, that's an increase. If the ratio is 1, that's 100%. That's like a threshold. Now, 23% increase in risk. But those who are exposed to high level, 33% increase in risk. Which one is more? The one that is more, okay, is the high exposure. Any question on how I interpret this? Any question? Like I said, you pay for the service. You deserve to be served better. If you need any clarification, please let me know. Okay, let me use this opportunity to appreciate those who provided me feedback. You know, on Friday, I asked you to rate the teaching and your understanding of what we've done so far. And of course, some students provided me a feedback. I want to appreciate you for doing that because, you know, with your feedback, that will actually enable me to be able to know what do I need to do more. You understand what I mean? You know, so now I want to go to the next slide right now. If you understand that, what we just done right now is situation where the level of exposure is more than 2. Okay. Now, I want to go into cohort studies. We've done cohort studies, situation where we actually follow some individuals over a period of time, and those individuals are currently exposed. We are waiting whether there's going to be an outcome. An outcome could be whether they're going to develop certain health condition or not. Okay, so that is now. But do you know that this practice is going to be problematic? Why is it that I need to consider case control study instead of going for cohorts? Okay. Okay. So we normally run away from a particular technique when that technique has an issue. Now, the issue with the cohort is, you know, situation where the outcome you are investigating is very rare. You remember the other time I gave an example using the aspirin to see whether it could reduce heart risk. I mean, what is it? Heart attack. Heart attack is very, very rare. Okay, which means using cohorts, I'm going to wait for a long time. Okay, and that's why. Okay, when outcome being investigated is very rare, it doesn't make sense using cohort study. Does that make sense? Okay, and let me also tell you this. Apart from, it means you're going to wait for a long time. That's why I said there's a long time period between the exposure of interest and the development of the disease, particularly when disease is very, very rare, like heart attack. Okay, and let me also tell you another problem here. It means you need to also recruit a large number of participants. When you are working with a rare occurrence of disease, You don't need small number of participants. You need large number of participants, and that is going to be costly. The more participants you recruit, the more the resources you commit in. Okay? And that's also why it is very expensive or very difficult to obtain exposure information from cohorts. Now, because of that, we normally consider a case control design. Okay? And in a case control design, don't forget, you actually have information, you already have information about those who have the disease and those who do not have, and you also have information about their exposure. You don't need to wait. Okay? Case control study does not involve follow up, like following participant. Okay? Now, and I said the goal of a case control study is the same as the goal of the cohort study. Of course, we all know whether cohort study or what is it called, case control study, actually attempt to estimate the magnitude of the association, between an exposure and an outcome. Okay, and I said because case control study employ what I call different sampling strategy. Of course, that give it a greater efficiency over the cohort studies. Okay, so I just wanted to take note of that. Now I want to go into an example now. Oh my God, I want to use a particular county I think in Massachusetts in the United States. This county is Plymouth, has 502,000 population as at the time we're getting this information. And of course, in this county, we've identified 13 people that are currently, they have the disease. They have a particular disease. Do you see the 13 people? Let's count them, whether they are 13, 1, 2, 3, 4. Yeah, that is 13. But out of these 13, okay, out of these 13, 7 is exposed. Do you see the mark? Do you see that blue dotted line that I put? Let's count it. The one, okay, let me do this. Give me 1 second. Oh, 1, 2, 3, 4, 5, 6, 7. Those are the ones that are exposed. Okay? But 13, all of them have the disease. Don't forget, this is a case control. In a case control, where the researcher will collect data, okay, on exposure. Those who already who are exposed, or those who have not or are not exposed, and those who have the disease, and those who do not. Okay. Now, based on this, I'm going to show you a table. Okay. Take a look at this. This is a table. What do I want to do? I want to measure association in a case control study. This is an example of case control study. Yeah, I told you the other time. How many have the disease? 13. The totality of the disease, 13. But 7 are exposed, 6 are not. Okay. And we also have information about, let me tell you this. In that very county, we did not focus on the whole 502,000. We have a population of an hypothetical population of focus, which is around 6,000. Take a look at that. That's what you see here. You see that when you add that up, that's 6,000, right? 6,647. Okay. And we got information that we got information about the totality of those who do not have the disease. And you can see 1,000 are exposed, but they do not have the disease. Okay. If you take a look at the section, those who do not have the disease, but are exposed, and those who do not have, who are not exposed and they do not have the disease. You can see that, right? Okay. So this is an example that I actually talk about. Like I said here, there's nothing like a follow-up. We only do follow-up in cohort. We don't do follow-up in case control. Now, let us analyze this. Okay? Well, what do we want to measure? We actually want to see if there's a connection between exposure and an outcome. Before I move on, is there anyone who has trouble time understanding the way I talk? Are you sure? Okay, if you understand what I've been explaining, I need you to give me a thumbs up. Okay, do not hide your feelings. If you don't understand, tell me. You pay for the service. Okay, now let's take a look at this now. You know what we obtained, what we calculate the other time, that we call cumulative incidence, 7 over total, right? 6 over total. What are we trying to do? It's more or less we are analyzing the likelihood of disease in different class, in those who are exposed and in those who are not. Okay, so when you do 7 over 1,007 and 6, take a look at that. That's what I'm doing here. You know, that will lead me to that. This will lead me to this, right? Then I will be able to get my risk ratio. Okay, you know, when I 4 of us get cumulative incidence in the 2 groups for exposed and unexposed, whatever I get, and then I'm going to find the risk ratio, the ratio of the 2, 6.52. Now, if I want to interpret 6.52, depending on, I have to look at what I put in the numerator. Numerator. Take a look at this. What do I put in the numerator correspond to the exposed? Don't forget, your interpretation depends on what you put in the numerator. Okay, when you put at the top. Okay, 6.52 now. What does that mean? Okay, suggesting those who are the risk factor exposure at 6.5 times the risk of getting the disease compared to those without the risk factor. Okay, 6.52 is a very strong association. Don't forget what Sir Hill said in his paper in 1965. You know, what we did the other time when he, in 1965, he published an article called Disease and Environment, okay, Association or Causation, where he provided some guidelines on how we can conclude causation based on association. You know, he mentioned having, you know, the strength of the relationship, strength of the association, even though that is not enough, okay? But here, 6.5 times. You know, what is a very strong one? You know, anything, any value that is significantly different from 1, because when the ratio is 1, okay, then it means it's dicey. The, you know, getting the disease, okay, in the 2 group is the same. If the ratio is 1, the moment the ratio is more than 1, that will favor the what we put in the numerator, okay. So what you put in the numerator is those who are exposed, which means those who are exposed, you know, they have you know, they are 6.5 times the risk of getting the disease. Any question? Okay, let me now tell you this. At times, we may not have information, okay? We may not have information about those who do not have the disease in the population. In that situation, we can take a sample, okay? When we take a sample, okay, take a look at this. I'm going to show you something now. Taking a sample. Don't forget, we always take sample, right? Take sample. Now, take a look at this. This is like 1% of what I choose before. Compare 10 and 56 to this. 10 and 56 to, give me 1 second. That is like a 1%. Take a look at this. Okay. 1,000, 5,600. I may not have that information. Okay. And I take a sample of that. I may take a sample of maybe like 10% of that. Okay. take a look at what I'm going to have. What I'm going to have is actually 10 and 56. And if I have 10 and 56, my total will be unknown. Why? My total unknown? Because I did not consider everyone in the hypothetical population who do not have the disease. Okay? But let me tell you this, there's no problem. And this is the reason why case control study will still give us something reasonable. Now, when we focus on, that certain number of, in the population, take a look at that. And when we now consider just 10% of that, let's see what happened. Let's see whether the risk ratio will be different using the case control. Now, if I want to do that, okay, this is a way to do that. Take a look at that. Okay, I'm going to find what we call hard. What do we mean by hard? Hard. Oh, okay. What do we mean by hard? Hard is the ratio of the probability of the outcome of interest to the probability. So when I say hard, okay, I mean the ratio of the probability of success to the probability of failure. That's what we mean by hard. Now, I needed to pay attention to this guy now. Okay, needed to pay attention to this guy now. Okay, take a look at this. 7/6 is the odd between the odd of those who have the disease in exposed and in non-exposed. Okay, now then you do the same as 10/56. Okay, for the other one, this will give you 6.53. At the end of the day, when you find the two odd ratio, if you don't want to base it on that, but if in a situation where you just want to base it on this, where you want to find the odd, okay, of, within the exposed, those who have the disease, the ratio of those who have the disease to those who do not have, okay, in the exposed, you also do the same in the non-exposed. Mathematically speaking, they're all going to give the same result. Take a look at that. Now, what is the difference between this result and when we have information about the totality? Okay, the difference is not, here we got 6.52, but here we got 6.53. Can you see how efficient is case control study? Do you see that? There's no significant difference in that. And that was why I said here, okay, that was why I said very close, said the order of the disease among the exposed and that, okay, very close to the risk ratio that I computed from data from the entire population. Okay, so you can see that is one of the way we know, the case control study is more efficient, than other type of observational study. Now, because of that, I'm gonna have these remarks. Okay, the sampling strategy for a case control is very different from that of cohort. That's why the fact that both have the goal. Don't forget, they both have the goal of estimating relationship between the two variables. But I needed to take a look at it. I'm trying to tell you the distinction between the two. In a case control, no follow-up, period. But in a cohort, we need a follow-up. Okay? So I think I just gave explanation. I think I've done that before. Now let me go to number 3. In a case control study, you cannot measure incidence, but you can start with the disease people are not disease, so you can now calculate the relative risk. The case control design is very efficient. I just demonstrated that right now. And case control studies are particularly useful when the outcome is rare. When the outcome is rare, you can't use cohort because you're going to wait forever using cohort. Cohorts involve like waiting for a a period, you're going to wait for a long time, particularly if you are focusing on heart attack. That's a rare disease. But case control study is very, very useful for such. Now, any question before I go to odds ratio as an estimate of risk ratio? Do you know that we got a situation where odds ratio can also be misleading? And we got a situation we can see trust or odds ratio despite having efficiency over the cohort study. Now, situation where, and that was why I said, I told you the other time, case control is actually being very useful when you're focusing more on rare disease. Now, provided disease is uncommon, when disease is uncommon, let's say less than 10%, less than 10%, very close to rare, right? Very close to rare. This sampling approach give an odd that is reasonable good estimate. Does that make sense? Case control, it is not all the time that it give a reasonable estimate. Only give a reasonable estimate with look at the threshold here when the prevalence rate of the disease is less than 10%. But if it is more, it exaggerates. Take a look at that. That's what I write here. You see this guy? When it's more than 10%, calculating odds ratio is going to exaggerate the estimated strength. And when you exaggerate the estimated magnitude of the relationship, you're actually going to mislead. Okay, now we want to demonstrate to you such example. Take a look at this guy. If you take a look at what I have, let me check here. Is that, oh, no mistake. I think I use, so you can see we still talk about the cumulative incident. Take a look at that. That divided by that. So you can see that guy. Okay. Now, let me tell you this. In a situation where if you take a look at this guy here, what do you have? 35.7%, 11.7%. They are all greater than 10%. Using a case odds ratio here, okay, to judge, okay, you will exaggerate the strength of the relationship. So the odds ratio is we give more reasonable estimate, or it can be relied upon when the incidence rate, the rate that you compute is actually less than 10%. But you can see that one is more. And alternative, and that's why you see, take a look at this. Calculating odds ratio, what has happened? 4.21. So odds ratio is not appropriate here, but what is appropriate is relative risk. So you asked about RR the other time, right? RR is relative risk, this guy. You see that? So you can see the relative risk give 3.06, right? Odds ratio give more. That's an exaggeration. Okay? That's an exaggeration. Exaggeration because it's more that what you see there is more than 10% threshold, and we don't expect odds ratio to give a reasonable estimate. But what we're going to consider is a relative risk. And how do we get relative risk? I put the formula here. You see 60 divided by 168, you divide that by that, then that is what you're going to have. And you see the way I computed odds ratio, 60 divided by 108. Now, you may want to say, what is it different? Take a look at this. That is, odds ratio here is finding the odds of disease within an exposed class. Within exposed, what is the odds of when I say what is the odds of having the disease and not having? Okay, it's going to be having the disease divided by not having. That's why you see 60 over 108. Okay, 60 over 108 in the exposed. I put that is the exposed in the numerator. Then in the non-exposed, I'm also going to find the odd of having the disease against not having the disease. And that is what you see here. So finding the ratio of that become odd ratio. That's an exaggeration. Okay. So in a situation, and how am I going to know whether I'm going to go with the odd ratio or the relative risk? Please pay attention to this guy. And I've mentioned that here. You see, more than 10%. Okay, to exaggerate. Okay. So now, instead of also consider an odd ratio, we now consider the relative risk. Now, in the relative risk, take a look at what I'm doing. That's actually talking about cumulative incidence. Cumulative. Okay? That is not an odd because I'm using total. The denominator is total. Okay? You can see total. Okay? Okay, now, any question before I move to something else? Okay, take a look at this. I want to go into another measure of association that we call risk differences. Oh, this is very easy. You know, in mathematics, if I want to know whether different exists, okay, I'm going to do algebra. What kind of algebra? Is either I subtract or I find a ratio, right? When I subtract, if the difference is 0, we're going to say there's no difference, right? When we do ratio, okay, what is the threshold for ratio? 1, right? Now, the risk difference is just subtracting the cumulative incidence in the exposed, the subscript, if you take a look at this, okay, cumulative incidence in the exposed, cumulative incidence in unexposed. We're subtracting them. Okay. Now, let's say for instance, we actually obtain this guy as you all know how we obtain cumulative incidence, right? Cumulative incidence is when you use that characteristics of incidence over total. Okay. Now, let's say for instance, we got 5.3 per 100 and 1.3 per 100 not exposed. For exposed, maybe this is what we got after we calculate the cumulative incidence for exposed and the cumulative incidence for not exposed. If I subtract them, what am I going to have? Subtracting them is like subtracting 5.3 minus 1.3. What does that give? That would be 4 per 100. Okay? The 4 per 100 is actually what you see here. Oh, give me 1 second. It's what you see here. You see that? 4 per 100. That's just like subtracting them. 4 per 100. Okay? So the excess of risk is 4 per 100. Okay? So that is what we actually mean. So this is very easy. The risk difference is just subtracting the cumulative incidence for exposed, or I mean subtracting the cumulative incidence for unexposed from exposed. Now I'm gonna go into this example. I want to award an extra credit. Okay, I want to award an extra credit. I need you to read this question and tell me the answer. I'm gonna take notes. Okay, maybe what I'm gonna do. Tell me the answer, and I'm gonna tell you whether you get it or not. I need you to read that. I need you to read that, and you tell me the answer. If you are ready, you tell me. You already know your answer. You tell me. Who is ready? What is your answer? Okay. Noted? Yes. If you agree with him, I need you to give me a thumbs up if you agree with him. If you don't agree, don't do that. Okay. How many? Okay. Okay, which means if you didn't do that, you didn't agree with the answer. It choose F. Okay. Now, those of you that agree with him and the person, send me a message for extra credits. Well, that is correct. It's just 24 power. What are you gonna do? You just subtract. This is risk differences. We're going to start consulting from next week, and I'm going to upload new material for consulting. This is where I'm actually going to stop today. Okay. Is there any question before I go? All good, right? Sure you all stay safe and have a lovely weekend. Bye for now, everyone.